Good afternoon. So I'm going to be talking to you about a small project that was improving efficiency in field collections and product delivery using EnerGIS collector application and Python. Just to prepare you, right off the bat, this was a small project, kind of a proof of concept project for our oil and gas operations groups, the cultural resources, wetlands groups, trying to show them that this is really something that could work for you, but this project itself has absolutely nothing to do with oil and gas. So a brief overview, I'm going to describe the project itself, its requirements and deliverables, the process to meet those, the challenges for improving efficiency that we encountered along the way, our results, and what we hope to do in the future with this. So this project was with the West Virginia State Historic Preservation Office, and it was a project to survey 2,500 features in the unincorporated areas, structures for possible inclusion in the National Historic Registry. So they gave us a prioritized list of 7 counties, and we have to just, starting with Tucker County, move on through until we've reached 2,500 features. The deliverables are a GIS database of point locations and attributes, reports on findings per county, and then completion of state-mandated forms for each one of these survey features. So the overall process is, I'm sure, familiar to most of you. It's boots on the ground, field data collections. Start with that. And we've got to process that field collected data back into our master data file, master database. Project lead has to review and correct data as necessary. And then we reconcile those corrections with the master database. And then in our case, we're populating these forms with the collected data. So the first challenge we had to deal with was trying to improve efficiency in all areas of the field data collection process. As you know, the conversion of GPS data is time consuming. First off, you've got the differential correction, conversion from the native file format to the shape file, porting all that into your master database. Then you're correcting the incorrect or missing data. And then, there's always that thing of somebody else mentioned before with, keeping those photographs all nicely related to the data that's collected. The solution we opted for was the ArcGIS collector application. There's no data conversion necessary here. You can download from ArcGIS Online once the data is collected from your feature services in shape files or file geodatabase format. File geodatabase, all domains are maintained across when the collector. It makes it easy for the field crews. And then the photographs are relationally linked to the data files. For us, the domain-driven selections for out in the field was really a big deal. So we had 28 features for each survey location they have to look at. 28 attributes they have to collect, and almost all those are domain-driven, and the largest one had 32 different selectable values in the domain. So with a standard GPS unit, that can be difficult. They're trying to scroll across the 28 different attributes, dealing with all those long lists. It's really a drag for them, and so the collector application with a tablet device really made it much simpler, much cleaner, much easier for them to use. So the kind of traditional field data collection setup for a project like this required a GPS unit, camera, photo log, and then in order to maintain a decent pace of collection, 2 field techs out in the field. One for camera photo log, one for GPS. Using collector, we've got a tablet application, a high resolution GNSS receiver, a Bluetooth link to the tablet, and then 1 field tech. So right off the bat, we've doubled our efficiency as far as man hours in the field. So something else I wanted to talk about with regards to challenges here is developing an efficient web application. Even with connected applications, when you've got maps and data maps that you're trying to put in an application, and when it's just too much, it affects the efficiency of downloading and accessing your data. And you can have the same issues even when working with offline. One of the requirements for this project, being in rural West Virginia, was that all of this had to happen in offline mode. So to start with, what you see is, there's a certain amount of base data that was required for them to effectively do their job in the field. But in the beginning planning stages, the field lead, or the project lead's like, oh, I want to see everything on here. And she wanted this county roads layer, and even clipped to the county and generalized 21,000 plus vertices in there. And that's a lot. So when I went to publish this for the first time up to ArcGIS Online, 15 minutes, hadn't even finished. I just scrapped it, said, listen, we can't do this. And they also wanted multiple base map images, imagery and USGS. Now that's no problem at all when you're working with connected services, and it can be done as well with disconnected services, but it still has an efficiency for how much work they're going to get done each day. Because with the scale that they're working at out in the field, their daily kind of project area is one USGS quad, and then they want to zoom down in for aerial imagery down to the level of 1 to 5,000. Can I tell that this is the house I'm standing in front of? At this level, doing that sync to offline can take 5 to 10 minutes per day, depending on network. So some days it's fast, some days it's slow. You never tell. So with two different base maps, yeah, it's doable. You sync one, you unsync, you switch base maps, you sync another. Up to 20 minutes a day, just right there before you're even out in the field. And then, of course, they wanted a custom base map. They said, well, we'd really love to have the historic USGS imagery on there as well. Okay, well, this can be done, but now we're talking tiled services, which really burn your credits big time as far as an ArcGIS Online account goes. So I guess my point is, you really, when you're dealing with project leads, you got to dial them back to just what is necessary for you to do the job. Yeah, lots of bells and whistles would be cool, but just what you need. Let's start with that. So the next challenge that we faced was integrating that, effectively and efficiently integrating that collected data into the online master database. So you download that file geodatabase from ArcGIS Online from their collected data, the day after they've collected it. Then the photos need to be extracted and named. The file needs to be appended to your master database. And then and there's ancillary fields that it's not necessary for field text to be filling out that also need to be populated. And the solution to this for us was Python. Python scripting allowed automatic extraction of the JPEGs, naming them with individual survey numbers to keep everything neat and clean. The field data is automatically appended, and then all those ancillary fields are auto-populated, and all that takes about 10 seconds per day of field collected data. So now, given how important Python has been to this project, I felt I would be remiss if I didn't show you some, eye-crossing lines of code. But what I really wanted to point with this is that what you'll see is I'm a huge fan and a proponent of the data access module. It was released in ArcPy in version 10.1. The data access module makes it so incredibly efficient to programmatically access, update, and create data that it's really fantastic, and it forms the backbone of all the Python scripts that were created for this project. So now the next challenge that we face is that correcting the field data. Once it's been returned and it's integrated in the database, the field text, they're trained, but in our case, they're not architectural historians, so they're not always going to get it right. The project lead doesn't know and doesn't have ArcGIS. So, well, how do we maximize the efficiency of getting all of these attributes accurately populated and then integrating that back into the master database? So what we did was we built kind of basically like a master QC tracking Excel table with porting all those domains from the master database into validation fields. This makes it incredibly easy for the project lead to be able to accurately correct the data and ensures coherence between the data that she returns and the database itself. And once again, Python was critical for the efficiency of this process. As you know, when you pull in an Excel table into ArcGIS, all those empty fields are null values. And we didn't want that, and you might see it later that there's an access to a part of what we did here that was, we couldn't have that at all. So built some scripts that scrub all those null values and then automatically form all the corrections from her QC table back to the master database. And again, a few seconds per day of collected data. And again, the data access module forms the core of this. So now the big push here is for efficiency for this project was these going from the database to these state mandated forms. So because these are state required forms, basically he said that they have to be exactly like this. So an iForm type solution was not going to be acceptable. There's 40 fields per form and 2,500 forms that have to be filled out. So the project lead, from the beginning said this is where we really need to make some headway. And so again, the solution was creating a Python XML generator, which basically just pulls all the required fields from the form or from the database into XML files. And then the field lead and the tech, it takes them about a minute per form to populate one of these by just pulling in that XML file. And then you get to your nice fully populated forms at the end. But I do want to say here that this was not, like using Python to do this was not our first go. When she first came to me and said, this is what would really help me is to be able to auto-populate these forms. My first thought was, well, we could just export from the database to Excel and then pull that into Word and do a mail merge. Use some VBA scripting to auto export all the individual mail merge sheets as XMLs, and then they could use that. But then the project lead got creative and came up with some ideas while she was working with the Excel QC sheet that really helped speed things along. So in red there we've got it's like the statement of significance block, the description of all the outbuildings, and then the general site description. Now all this stuff is not part of the database, but when she was going through that QC table, she's saying, what if I just added fields and I could just paste all this stuff in and then you could pull that in as well. I said, well, yeah, that'd be a great idea, but then it was like, well, I don't want to put that all in the database, and then I just thought, let's just do all of this in Python and we can forget the Word, and then we can also add some really nice logic blocks through Python to be able to handle things like there's radio buttons their values are driven by the various attributes, and there's certain fields that had to be filled in a certain manner depending on attributes. And it's like with Python that was incredibly easy to accomplish that. So on to results here. So for the collector app versus traditional GPS and camera, as I already said, we went from down to 1 field tech from 2, so right away. That's doubling our efficiency there. I estimate I'd probably save an hour per day of field collected data in not having to go from GPS unit into the database and do all that transfer and conversion and matching, putting in all those attributes. And then the photo export, that's at least 15 minutes a day there using Python scripting versus having to do it by hand. Because I don't know if you've ever dealt with this, but once you download that file geodatabase with the photo attachments, it's in the attachment table as a blob file, and the names mean nothing. And the only way to get them out is to open the attribute table, go line by line, access the attachment manager, and export them manually. A drag, and Python really helps that out. And the project lead estimated 2 days saved over the project in just renaming those photos. 2,500 sites, multiple photos per site. And then the real seller for us was this auto-generated filling the forms using XML sheets. They estimate at least an hour saved per form, which would, over the life of the project, 2,500 hours. It's an enormous savings right there. And so as far as future plans, like I said, this was really kind of a proof of concept. The project lead proposed this whole thing, knowing that the only way she was going to be able to do this effectively was if we used something like collector and some other technologies to be able to do this efficiently and for the price that they bid it at. And we thought, well, if we can do this and really show how good this is, then we can rope in some of these other groups that are resistant, like our cultural resources and our wetlands group for the OGA business. And we're really looking to transition this to all of their field work as well. And then, as you've seen, I'm a huge proponent of Python, leverage it at every opportunity. I use it almost every single day. It cuts an enormous amount of drudge work, and it leaves you free to focus on much more interesting analysis tasks. And finally, I'd like to make some acknowledgements to Hannah Dye. She's our architectural historian, the project lead that got us this project and wrote me in and got me doing some fun stuff. And Courtney Smith, our field technician, she's the one out there every day with that GNSS receiver in a little pocket on top of her baseball cap, like a good field nerd. I wanted to get a photo of her, but she wouldn't go for it. And that's all I have. I'll get you to Beer 30 as fast as possible. Any questions?